and thank you, Mike, for inviting me. I'm the executive director at the OpenStack Foundation, which is the nonprofit that organizes and manages the community around OpenStack. So as the nonprofit guy coming up after these senior leaders at successful commercial technology companies, I feel a little bit like maybe the Bernie Sanders of the day. But I like commercial success too. We have an awesome commercial ecosystem around OpenStack, and actually VMware, Intel, QCT are all contributors and supporters of OpenStack and have OpenStack products. So one of the things that I really like about the job that I have is I get to travel around a lot and talk to users, and so I really value that direct feedback and that direct connection with the problems that people are solving and what they're facing today in the landscape. And Mike and Diane and Ray have all covered some of the same slides that I have. So I think what I might do is skip through some of those and focus more on some of the use cases, because I think that there's a lot of really interesting things that are happening out there, but there are still a lot of pieces which are not technology related that people are trying to figure out. There's a lot of cultural shifts and a lot of cultural changes that have to happen to make this work. Just some quick stats on OpenStack. How many of you are familiar with OpenStack? Okay, good. So it's a very large open source community, one of the largest that has ever existed. It's very global. Mike actually invited me to this event in Taipei a couple of months ago. And we have people all over the world who contribute to OpenStack. We have thousands of OpenStack deployments in all over the world again. And a lot of companies who take those services that the upstream developers contribute and turn them into products that are easier to consume and are nicely packaged up. A lot of people, though, they say, okay, well, it's open source. What are people really using it for? Is it just test dev? We do a survey every 6 months. Our last survey showed that of those deployments that we've cataloged, 65% of them are now in production. And we are just wrapping up our most recent version of this survey, and that number has actually gone up even more. So OpenStack and open source, it's legitimate. It can be used for real workloads. And that's actually 33% higher than just a year ago. Half of the Fortune 100 now use OpenStack in some way in their businesses. And if you look at some of the companies who are out there contributing to OpenStack and talking publicly about what they're doing, there's the largest companies in the world that are using this, and they say it's because, just like we've already heard, software is strategic to every business now. And if you look at this, Walmart, largest company in the world, largest retailer. AT&T, the largest integrated carrier. China Mobile, largest mobile company in the world, 850 million subscribers. State Grid of China, the largest power company in the world. Volkswagen, largest auto manufacturer. This is something that it affects all industries and all companies and all geographies. It's not just massive companies, though. There are, again, hundreds and hundreds of companies out there who are building enterprise private clouds, public clouds, doing research, doing NFV and telecoms with OpenStack. And the thing that is interesting to me, and it kind of, again, feeds into what we've been hearing. There are so many technologies out there, and what these companies value is a way to unify those technologies with a standard set of APIs. OpenStack provides that. So, we've heard demand for infrastructure is exploding. There are a lot of things driving that. IoT is one big driver. 50 billion devices by 2020 that are going to be all out there generating data, pushing it to cloud environments. And those are not just phones and Nest thermostats and iPads. Those are more and more industrial devices and things like smart cars. Mario Mueller from Volkswagen, he spoke recently at an OpenStack event and talked about how for Volkswagen, the challenge they face is it's no longer enough to just be a great car manufacturer, physically making, bending steel and turning it into automobiles. To compete now in the automotive industry, they have to be a technology company. And so they have to think about how do they look at in-car entertainment, how do they look at autonomous driving, and it's all driven by software, data, and analytics, and they really have to shift to that. But as you think about all of these different use cases, they all fundamentally come down to having to process, store, and move data. So you have to have physical resources somewhere that you are operating, that you're running these applications on. And that is what we're here today talking about. How do you bring all of those pieces together and automate them so that you can manage this? And I think that that one of the stats that some analysts came out with earlier this year was that as you look at the trends over the next 10 to 15 years, there's going to be a need for another 400 million servers. And that's unbelievable, really, when you think about it. And it seems high to me. I would love if that were true, but let's say that it's only half of that. It's still an incredible amount of infrastructure that's going online all over the world. And so when you look at what's driving that, it's companies like AT&T. AT&T, between when the iPhone launched and the end of last year, they saw a 150,000% increase in the data on their network. And so in less than a decade, they went from being a phone company to a mobile data company. And it just changed the business that they're in. And so that is driving this need for massive amounts of infrastructure that we just can't manage them the way that we used to. When I started working with servers 20 years ago, I would SSH into a server, install some stuff, log out, log into another server, install some stuff, and I'm done. I've got my 2 servers and they're load balanced and ready to go. You can't do that anymore. It has to be programmable infrastructure. You have to have all of those layers that we just heard about that give you infrastructure, application tools, cloud native frameworks, and you have to really automate them and tie them together so that you're delivering value to whatever is the business goal on top of it. SAP, they do industrial Internet of Things. They have a platform that's used for industrial control systems that runs on top of OpenStack and Cloud Foundry. And then there's a product called Siemens MindSphere that is layered on top of that. And you think, why would you run a factory on top of a cloud? It's because just like everything else, factories are more instrumented than ever, generating more data than ever, and they need to be more agile than ever. So all of these things come together, and they just highlight that you have to have this ability to have programmable access to bare metal, to virtual machines, to containers, be able to tie it all together. And that's what what OpenStack is focused on creating and delivering. So one of the other things that I think is important to think about from the open source perspective, we very community oriented. Our goal is to bring people together from all different companies and all different countries to collaborate and create technology together. But even as big as the OpenStack community is, this future that we're talking about is too big for any one company, any one country, even any one community. And I think that we need to look to successes that we've seen in the past. The LAMP stack to me is a really interesting analogy, because if you go through and you look at the trends of when we've seen just kind of these inflection points and the value that technology has delivered, you obviously think of things like mainframe to client server, desktop, those transitions. What the LAMP stack did was it changed the World Wide Web from being a collection of static content to what we all accept today, which is that it's extremely dynamic. Every company you work with has a customer portal where you can go pay your bill and get support. It wasn't that way just 20 years ago. And one of the things that drove that was the coming together of these technologies that were built by different teams, sometimes different licenses, different languages, that in a way that enabled tens of millions of applications to be built really rapidly. And I think that we are coming to that inflection point for cloud applications. Because as you look at all of these drivers, whether it's machine learning, artificial intelligence, IoT, buzzword, whatever, what they all require are massive amounts of programmable compute, storage, and networking across public clouds and private clouds. And so, again, from our survey, we go out and we ask people, what are the technologies that you are using in addition to cloud? And this is from our last survey that shows that things like Kubernetes at the container orchestration layer, Cloud Foundry at the PaaS layer, OpenShift at the PaaS layer, these things are actually really starting to get traction. This is not which things are you interested in, these are what are you using today. And so as you put these together, that's when you end up with really powerful solutions. And I think that's a great focus for a day like this, where we have people from all across the industry together in one place. Let's think about how do we collaborate. I want to leave you with one anecdote that I don't have slides for because it's from a trip that I just got back from. I was able to go to Cambridge last week and talk to some of the people there who run the IT for Cambridge University. So the Square Kilometer Array is a very large global effort to build. It will be the biggest scientific instrument that we have ever built as humanity. And it will give us the highest resolution and the most complete pictures of the universe that we've ever had. The Square Kilometer Array, though, is different than any other telescope or any other space instrument that we've built, because it's actually a deconstructed radio telescope that is software defined. So it's made up of, rather than a single telescope like you'd think of a pirate using, it's actually all of these little different kinds of radio antennas that they spread out in the desert in Western Africa and Western Australia and South Africa. And the raw data from that gets fed to a system that joins all of the images, all of the data together to create pictures of the sky. And then it shares that out to a global network of astronomers who can study this. When the Square Kilometer Array goes online in the next few years, in order to accomplish that software-defined telescope image generation, they need 250 petaflops of computing power. And their antennas will generate 5,000 petabytes of data a day. And within 10 years, it'll be 100,000 petabytes of data as they finish the deployment of all of these antennas. This is just one science project. So, as you think about the world over the next 10 or 15 years, and projects like this in the research field, the things that are happening in industry, you can see that the opportunity for all of us is, as Diane said, just so exciting right now. It's a great time to be in this field. So, thank you, Mike, for organizing this day and inviting us. And I think it's a great opportunity to think big and to think about what we can all do together and go out and really provide solutions to meet this amazing demand. Thank you.